In the previous video, we had calculated the relative velocity of a two particle system. So this is a second approach for that question. Suppose you have a two particle system, which is m1 and m2 separated by distance r. Originally, these two were separated by infinite distance. So m2 and m1 were separated by infinite distance. So when you have a two particle system, so when there is no external force acting on it, these two particles masses can be written as a single mass, which we call reduced mass. So the reduced mass of the system is actually m1 m2 by m1 plus m2. Whenever you write the relative kinetic, the kinetic energy, you will be writing the reduced mass, which we all call mu, right? So when these particles, when they are separated originally, the total initial energy of the system is zero. Under the action of mutual attraction, when they come and they are right now at a distance r, due to this distance there is a potential energy of minus of g into m1 m2 by r. So as they approach each other under the action of the force, gravitational force, they would have acquired some velocity right now. That relative velocity acquired is v. Then corresponding to that velocity, they will have kinetic energy half mv square. So the kinetic energy, when you write the relative velocity, these two masses should be reduced to write the reduced mass half mu into v square. So the sum of this kinetic energy and this potential energy will still be equal to zero, because no external force acted on the system, only under the mutual attraction they move towards each other. Then according to conservation of energy, the total initial energy is zero, total final energy is half mu v square plus of minus g m1 m2 by r. Because we know this is the expression for potential energy. So here for m, we are going to substitute this reduced mass. So when you write this, half into m1 m2 by m1 plus m2 into v square minus g m1 m2 by r, that is equal to 0. When you bring this onto the other side, we can write like this. So this is equal to this. So m1 m2 will be cancelled. So v square equal to g into m1 plus m2 by r, and this 2 multiplies there, so it is 2. Then their relative velocity of approach is 2g into m1 plus m2 by r.